Hi everyone. This video is designed to serve as the second in a series that I'm putting together on fixed effects regression analysis in SPSS for those cases where you have repeated measures or longitudinal data. So in my first video I demonstrated fixed effects regression with student data where students were measured repeatedly over time in terms of their science grades or science performance. And we were predicting change over time in their performance as a function of perceived ability in math, language, and science, and then also their math grades. So this video just kind of picks up where that one left off, and the main focus in this video was to show you how it would be possible if you wanted to carry out a one-way repeated measures ANOVA in SPSS by way of using a fixed effects regression model. So I will say that under most circumstances you'll probably just want to carry out the standard one-way repeated measures ANOVA since the fixed effects regression approach can be a little bit more convoluted. Nevertheless, I wanted to add this to the series to give you a little bit better understanding about how the fixed effects regression approach is actually working. And in particular, we're going to be using the least squares dummy variable approach when carrying out our analysis. So what I'm going to do is start out by demonstrating a one-way repeated measures ANOVA, and then I'm going to reparameterize that model by way of fixed effects regression. So the data set that you see on your screen is the data that we'll be working with, and basically we have student data. We have fictional student data, basically 60 cases, where students were measured at 4 time points in terms of their motivation. So you can see that we have motivation at time 1, 2, 3, and 4. So this data is in wide format, meaning that basically we have one row per student, and the measurement for at each time point is reflected in a different variable. So we have time 1, 2, 3, and 4 again. So later on, when we carry out our analysis using a fixed effects regression approach, we are going to have to restructure our data from wide format to long format. So I'll show you how to do that shortly. I do want to mention that underneath the video description you will find a link to this data file that you see on your screen, so you can download the data to follow along. You'll also find a link to a supplemental PowerPoint that will contain some additional details that you might find helpful. So let's go ahead and get started by just carrying out a one-way repeated measures ANOVA. So to do that, I'm going to go to Analyze, click on General Linear Model, and go down to repeated measures, and where it says number of levels, because we have 4 measurement occasions, I'm going to type 4 right there, and I can change the within subject factor name to something a little bit more descriptive. I'll call it time, and we'll press add. If I wanted to go ahead and add in a measure name, I could, but I'm just going to leave this blank. It's not really necessary to add anything in right here. We'll click define, and we'll move our variables over to the within subjects variable box, and I'm only going to select a couple of things in terms of options so that basically to facilitate the comparison with the fixed effects approach that I'm going to demonstrate shortly. So I'm going to press the EM means button, that's estimated marginal means, and I'm going to move overall and time to this display means box 4. We'll click on continue, and then for options I'm going to select descriptives and effect size. So I'm leaving a lot of other things that I ordinarily would select unclicked. So we'll click on continue and then on OK, and we get our output. You'll notice that with our descriptive statistics we have the means on motivation at times 1, 2, 3, and 4. So you can see that the means at times 2 and 4 are actually a little bit higher than they are at times 1 and 3. So we'll scroll down, and we're going to look in our table containing the tests of within subjects effects. So we have time right here, and we're going to focus our attention on this first row. You'll see that we have this F test that's given and significance levels. So you can see that just looking at the information right here, that would lead us to conclude that there is significant variation in the means on motivation over time. You'll also see that we have our partial a squared value that's given right here, and I'll show you, I'll talk more about this later on when we run our regression. So at this point, let's go ahead and go back to our data set. And again, it's in wide format, so to carry out our analysis using a fixed effects regression approach, I need to restructure the data from wide format to long format. So to do that, I'll click on Data and then go down to Restructure right here. And it says, what do you want to do? We're going to restructure the selected variables into cases. So we'll press Next. And it asks, how many variable groups do you want to restructure? Well, we only have one variable group because we have the same variable measured over 4 time points. So we're going to leave the set at 1. We'll click Next. And then you'll see it says target variable right here. I'm going to change this to call this motivation. And we're going to move these variables over to this box right here, so variables to be transposed. So in our new data set, essentially what's going to happen is it's going to contain a new variable called motivation that's going to contain the measurements across the 4 time points, and then also it's going to be done by student ID, so there'll be an ID variable in there as well. So we'll click Next. It asks, how many index variables do you want to create? So I'm going to leave this set at 1, and the index variable is just going to reflect measurement occasion or time point. So we'll click Next and then finish it out. And so now when we go into our data set, you'll see it's in long format. So you'll see we have our variable ID, we have our index variable, and then we have our repeated measures for motivation. So you'll see that under ID, basically our first 4 rows of data reflect student 1. The next 4 rows of data are for student 2. Then the next 4 for student 3, and so forth. So you'll notice then that we have student 1 measured at times 1, 2, 3, and 4 on motivation. So that's the student's motivation scores at those 4 time points. Then we have student 2 measured at those 4 time points on motivation, and so forth. So at this point, I'm going to stop and or pause for a second, and I'm going to rename this data set because I don't want to inadvertently save over my data that's already in wide format. Okay, so now I've saved the data set just to reflect the fact that we're working with our data in long format. And at this point, we're going to have to create sets of dummy variables. So we're going to create a set of dummy variables that reflect each individual student and a set of dummy variables that reflect the different time points. So the first thing to kind of note is that if you're working with a previous version of SPSS, you may not have the option that I have available, in which case you might have to use the recode command sort of more manually, if you will. But thankfully in SPSS version 28 we do have an automatic recode option. So if we go to transform and then go down to create dummy variables right there, that's it, which is wonderful. So at this point I'm going to start off by creating dummy variables to reflect measurement occasion. So to do that, I'm going to move my index 1 variable over to this dummy variables box, and for root names I'll call this time, for lack of a better name. Now just keep in mind too that when you're creating dummy variables through this approach, you're going to need to make sure that those variables that you're creating dummies for are recognized as categorical. So in both cases, the index and ID variables, both of those are given, it's basically recognizing them as nominal variables, if you will, given the 3 circles. But nevertheless, just keep that in mind, otherwise it's not going to work properly. So we'll click on OK, and now when I look in my data set, you'll see it says time_1, time_2, time_3, time_4. So basically for each measurement occasion, time 1 measurement occasion for each student, you're going to get a coding of 1, 0, 0, 0. Across the 4 dummy variables. So you can see that's the same for student 1, for student 2 at time 1, student 3 at time 1, and so forth. Then for time 2, you'll see that we have a 0 on the first dummy variable, 1 on the second, 0, and 0 for the third and fourth. So it's the same for, again, the first student, our second student right here, our third student, and so forth. Then, no big surprise, when we look at the third measurement occasion, we have 0, 0, 1, 0. And then for the fourth measurement occasion right here, we would have 0, 0, 0, and 1. So when we carry out our regression analysis, we're only going to be using 3 of the 4 dummy variables. So if you have any background in dummy variable coding, in a standard regression context where you're basically using dummy variables to reflect a categorical predictor variable, basically the number of dummy variables that you would include is equal to the number of categories minus 1. So in our case, we're going to be using dummy variables 2, 3, and 4, and we're going to treat the first measurement occasion as the reference category or reference point, if you will. Basically, time 1 is the reference point that we're comparing all of the other time points against. Now we will go ahead and create dummy variables reflecting the students themselves. So to do that, we'll go back to transform, create dummy variables. I'm going to reset this, and I'll move in this case, we'll move ID over to the dummy variable box. For a root name, I'll just go ahead and call this ID and click on OK. And so now when we look at our data set, we've added in those dummy variables reflecting students. So basically for student 1, irrespective of time point, it's going to be the same coding. You'll see that student 1 is given a value of 1 on the ID underscore 1 variable, and values of 0 on all of the remaining dummy variables. So basically, just keep in mind that we are going to have ID underscore 1 through ID underscore 60 to reflect 60 students. So that's the coding of student 1 across all 60 of those dummy variables. Then for student 2, they would have values of 1 on the ID underscore 2 variable and zeros on all the remaining ones. Then for student 3, values of 1 on the ID underscore 3 variable and zeros on all of the remaining. So for our regression analysis, though, as we did with time, we're not going to be using all of the dummy variables. We're going to be using basically the number of the dummy variables for 59 of the 60 students. So I'm going to treat the first student as a reference student or reference category, if you will. So I'm going to be using the dummy variables ID underscore 2 all the way through ID underscore 60. So now we're ready to carry out our regression analysis. So I'm going to click on Analyze, go down to Regression and Linear, and we'll move the motivation variable to the dependent variable box, and I'm going to move my student dummy variables over to the independent variables box. Just keeping in mind we're not going to be adding in that first dummy variable. So in this case, we'll move all of these dummy variables over to the independent variables box. We'll press Next, and then we'll do the same thing with respect to time. But again, we're going to be using the dummy variables time underscore 2 through time underscore 4, leaving off the time underscore 1 dummy variable. So I'll move these over to block 2, and then for statistics I'll click on R squared change and then click on continue, and now we're ready to go. So I'll click on OK. And so you'll see variables entered. We have 2 models that have been generated. Model 1 contains all of the dummy variables associated with the students, and that model is essentially capturing all of the between student variability and motivation. And then Model 2 is incorporating all those dummy variables for student as well as the time dummy variables. So when we scroll down and look at our model summary table, you can see that we have for Model 1 our R-squared value of 0.246. So basically what that's telling us is that about 24.6% of the variation in student motivation is occurring between students. So that's essentially the between student variability in motivation. And you'll see that we have our Model 1 ANOVA results that's given right here, and you can see it's not statistically significant. So I will say though that when it comes to reporting on Model 1, for instance, it's really not telling us a whole lot of information that we're terribly interested in, because all it's doing is talking about the variability that's occurring occurring between students. So that's not really what we're really interested in knowing about. We're interested in knowing about change within students. So we can look then at Model 2 right here, and you'll see that we have an R-square value of 0.807, and you can see that that model is statistically significant. So in this case, we have both the dummy variables for the students as well as the dummy variables for time. Both of those are combining to account for about 80.7% of the variation. And again, this is not really telling us exactly what we want to know, because it is an amalgamation of both between and within variability. So it's not really getting at our question of, is there significant change over time in terms of motivation? So to address that particular question, we can look at the R-squared change right here, and this is for, it says Model 2. So this is a change from Model 1 to Model 2, which is 0.561. And so basically what that's telling us is that by adding in the time dummy variables, we're accounting for an additional 56.1% of the variation over and above the variation that's reflecting between student variability. And you can see then that we have an F change. So this is an F test, which is testing that increment in R square. And so you can see that that is statistically significant. And notice that that F change value and the degrees of freedom and the significance test value, all of those are the same values that we saw previously. If we go back up and look at our test of within subjects effects, you'll see there's our F value of 171.683, and there's our P value. There's our degrees of freedom due to associated with our within factor time, and then we also have the error degrees of freedom as well. So all of that is exactly the same as as what we saw with the test of the change in R square from Model 1 to Model 2. Now, as we scroll back down, though, just keep in mind that that change in R square is really, or the R square value for that Model 2 is reflecting the proportion of variation accounted for by both the between student and within student factors. And that change in R square is reflecting that unique proportion of variation accounted for by our time factors, basically the within factors. Now, we could also compute an index of the proportion of variation in motivation after removing all of the between student variability. And so that's going to come in the form of a squared multiple partial R. So to compute that, all we need to do is to take this R squared change that we have right here that we see with our Model 2. If we take that and divide it by 1 minus the R square value from Model 1. So let's go ahead and do that. So again, kind of going back, let me just recircle this right here. There's our R square change and the R square from Model 1 that's given right there. So in this case, we'll take 0.561 and we'll divide that by, and I'm going to parenthesis 1 minus 0.246 in parenthesis there, and equals, and you'll see it says 0.744. So you'll notice then that if we scroll back up and we look at our test of within subjects effects, the partial eta squared is that 0.744. So in other words, that partial eta squared that you're seeing right there is reflecting the proportion of variation in motivation that's accounted for by time after we remove all of the between student differences or between student variation in motivation. So now let's scroll down and look at our coefficients tables. You'll see that we have coefficients for Model 1 and Model 2. So there's the coefficients for Model 1, and basically the results associated with Model 1 are not going to be particularly interesting or informative. So really we need to go down to Model 2 to get more useful information. And in particular, what we want to focus our attention on is not the dummy variables or the intercept that we see for that model, but rather the dummy variables for our time factors. So if we go down and we look where it says index, we have, this is just the way it's kind of coming out in SPSS right here. It's not giving me the time underscore, 1, 2, 3, or 4 or whatever. It's just, it says index 1 is equal to 2. So that's really our dummy variable. Our first dummy variable, and then the slope right here is reflecting the difference in means between times 1 and 2. So that 4.75 is the difference in motivation between time 1 and 2, and basically that positive value right there is indicating that at time the time 2 mean on motivation is 4.75 points higher than the time 1 mean, and you can see the difference in those means is statistically significant. Then for the next dummy variable, where it says index 1 equals 3, this is reflecting, the slope is reflecting the comparison in means between time 1 and time 3, and so that 0.75, that positive value, is indicating that the mean on motivation at time 3 is 0.75 points higher than the mean at time 1, and you can see that that difference would not be significant at the conventional 0.05 level. And then we have the last dummy variable where it says index 1 equals 4. So that's basically the comparison between time 1 and time 4. So the slope, which is positive right here, is indicating that the mean on motivation at time 4 is 8.25 points higher than the mean at time 1. And you can see that that difference in means is statistically significant. And if you wanted to prove it to yourself that that's what those slopes actually are representing, all you'd need to do is just go back up to your table containing your descriptives, or you could go down here to your estimated marginal means. Those are going to be the same. And so in a nutshell, you can compute the difference between time 2 and time 1. So if I take the time 2 mean and subtract the time 1 mean, that's going to give me the slope for the first dummy variable. If I take the time 3 mean and subtract the time 1 mean, that's going to get me the slope for the second dummy variable. And then if I take the time 4 mean and subtract the time 1 mean, that's going to get me that third slope within our regression model for that third dummy variable. Okay, so that pretty well wraps up this video presentation, and I appreciate you watching.